Welcome to Spring LIB.
Okay, so here we have a proton that's moving in an accelerator with velocity 1 times 10 to the 8 meters per second. So you'll notice that this is on the same order of magnitude as the speed of light, which is 3 times 10 to the 8 meters per second. And so if you cancel out if you divide v by c, you can cancel out the 10 to the 8 factors. What you end up with is that v over c is actually 1/3. So initially, your velocity is 1/3 the speed of light. Okay? And the question asks, what factor will the kinetic energy be increased by if the speed is increased to v2 equals twice this, 2/3 of c. Okay, let's call this v1. So to answer this question, you need to take a ratio of kinetic energies, and kinetic energies come from equation 26-5b. And that is gamma minus 1 times mc squared. We'll leave everything here in terms of mc squareds because when you take the ratio, they'll be the same thing. They will cancel. And so your gamma minus 1 is really the deciding factor in what this answer will be. So you have this equation. And so let's compute Ke for the first case. Velocity is 1/3 the speed of light. Okay, so let's call that K1. And that would be gamma minus 1 times mc squared, which would be 1 over square root of 1 minus 1/3 squared times mc squared. Oh, pardon me, there's a -1 over there as well. So this minus 1 times mc squared, and you get, this turns into 1/9. So 1 over all of this minus 1 will give you 0.0607 times mc squared. Again, leave the answer in terms of mc squared because it'll be easier to take the ratio. When speed is increased to twice this, so 2/3 the speed of light, kinetic energy will be denoted by K2 will be 1 over square root of 1 minus, now it's 2/3 the speed of light. Note that this factor of c here on the numerator cancels with a c on the denominator, which is why we don't have any c's in here. Subtract 1 from that, times mc squared. So here you get a 4/9, whereas here you had a 1/9. So you work that out, and you get 0.3416 times mc squared. Okay, now all you have to do is take the ratio of the second kinetic energy by the first kinetic energy, or nu over initial. So K2 over K1, and that's equal to 0.3416 mc squared over 0.0607 mc squared. Your mc squareds cancel. This is why we why we use that, carried that factor all the way through. So you don't have to worry about that at all. And this comes out to 5.6. Therefore, K2, kinetic energy, is increased by 5.6 times the initial. And that's your answer.